Alright, this was a test on circles. So this lesson will be everything about circles, graphing them, their equations, intersections, all that good stuff. Please put your pencils down. To get the benefit out of this tutorial, you're going to want to watch how I do things and then go back and get the practice by doing the problems yourself. Okay, identifying the center of the circle. Well, the center will be the opposite of these, so it's going to be -2, +3. The radius, well, this is the radius squared. So if I take the square root of this, that's going to give me the radius, which is 7. Now, as far as graphing the circle, if the center is at -2, 3, and then the radius is 7, so that's 2, 4, 6, 7. Okay, so 7, this is at 3. Alright, so I just went 7 in all directions. And that's going to show me where my circle is. So then you can just go ahead and graph it. I'm going to cheat a little bit and use my technology like I do. Alright, so your circle should look something like that. Alright, I guess that's it for number 1. Now, given the circle with a diameter that has these endpoints, find the center and the radius and write an equation in standard form. Okay, that's not too bad. So you should have drawn yourself a circle so you have something to look at. Alright, it has these endpoints. So 3, 6. Let's just say it's here. Alright, so let's call this 3, 6. And let's see. They're talking diameter, so you should be picturing a segment going right through the center of the circle, because that what I just drew would be the diameter. Alright, so the center, let's say, is here, whatever that is, and we have this other point over here, so -5, 4. Alright, so you should have drawn a picture similar to this. Let's find the center first, because that's just so easy. Let's find the center. The center is the midpoint of the diameter here. So we'll just use our knowledge of midpoint. To find the midpoint, you just do the average of these coordinates, add them up and divide by 2. So if I do -5 + 3 divided by 2, that should give me the x value of the center. It's the midpoint. And if I do 4 + 6 divided by 2, that will give me the y value of the center. So that's going to lead me to, so -5 + 3 is -2 over 2, and that's 10 over 2. Okay, so that's -1, 5. So that is the center of my circle, -1, 5. I could put it in here. Why not? Now, so I've got the center. That gives me the left side of the equation. So looking at the center, my equation is going to start off x + 1 squared plus y - 5 squared equals. Now, remember, in this position right here, we have the radius squared. So all we need is the radius, so we can square it, and then we'll be finished. And this is kind of a hint to you, because we had to find the radius anyway. So, you could either, now that we have the center, you could just use the distance formula to find out how far apart these are. Or I could find the distance using the original 2 points and then cutting that in half. I think I'll use the original 2 points mostly because of partial credit. If I got the center wrong and I use it, then I'll automatically get the radius wrong also. Alright, but if I go back to the given points, then maybe even if I got the center wrong, I can still get partial credit. So let's find the diameter. Alright, the diameter should be, and I'm just using the distance formula to find the distance between these 2 points. So that's x minus x squared plus y minus y squared. So I'm talking about, I think I'll do it this way. I'm going to do 3 minus negative 5. Okay, which is the same as 3 plus 5, by the way, squared. And then I'm going to do 6 minus 4 squared. Okay, this is the diameter, remember. So, if I do these calculations, that is 2 radical 17. Okay, that means the radius the diameter is the whole way. The radius is half of this. So the radius should be 2 radical 17 divided by 2. And obviously those 2's are just going to cancel out. So the radius is radical 17. Alright? But in the formula, we actually need the radius squared. So if the radius is radical 17, if I want the radius squared, then I'm going to square both sides. Okay? And that is going to give me that the radius squared is just 17. Alright, don't believe me? If I do the square root of 17 and then I square it, you see I get 17. Okay? So that's why I should just have 17 right here on the end. And that is how you write that equation in standard form. Okay, I forgot to write down the radius. The radius was the square root of 17. Alright, so that's how you do number 2. Alright, I'm going to solve number 3 by 2 completely different methods. The first method is to solve it by graphing. So if you're interested in learning how to do it this way, keep watching the video. If you want to skip this and just watch how to solve it algebraically, which is where we'll plug in the values and just solve it out, not needing a graph at all, then you're going to want to skip ahead and look for a box that says method number 2, solve algebraically, to pop up. Okay, method number 1, solving by graphing. If I want to solve this by graphing, first I need to rewrite this in standard form. And that's the one where we have to complete the square. So I've got x squared minus 2x, and I'm going to leave a space here. And then I've got y squared minus 2y, and I'm going to leave a space. Okay, and that's equal to 6. So writing this in standard form is where I go, okay, half of the middle squared. So half of this is 1. 1 squared is 1. So I'm going to have to add 1 to both sides. Alright, a common mistake is to forget the plus 1 on the right hand side. Meanwhile, right here is the same thing happening. So half of 2 is 1. 1 squared is 1. And again, I need to add that to both sides of the equation. Alright, so then we're going to factor this, and it should factor as the same thing twice. So for example, this would factor as x minus 1 times x minus 1. And the y's, this part is going to factor as y minus 1 times y minus 1. Alright, so that equals 8. Okay, so this is going to give us x minus 1 squared plus y minus 1 squared is equal to 8. So now that we have the equation in standard form, we can go ahead and graph the equation. So if I graph this, the center, alright, looking at this equation, that means the center is going to be at 1, 1. Okay, so 1, 1. So here's the center of our circle. Now, this 8 is the radius squared. Alright, so that means the radius is the square root of 8. And we'll need a decimal for that. So square root of 8 is about 2.8. Okay, so if we go 2.8 in all directions, that's going to put us here, 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 and here. Alright, so you can visualize your circle from there. Alright, next we need to graph this line so we can see where it crosses. Okay, so we've got this line y plus x equals 2. If we subtract x from both sides, then we have y equals negative x plus 2. And so we can graph this. So the y-intercept is 2, so it'll start off here. And then the slope is negative 1, so that's like negative 1 over 1. So that's going down 1 over 1 like this. And we can continue the pattern to the left like this. Alright, so you can see that the line is doing this. Alright, so that is our line. And so the solution of this system is going to be where these two intersect. So you can see that the intersection points are here and here. Alright, so that means the solutions are going to be negative 1, 3, and from this value we have 3, negative 1. So those are the two solutions. Alright, so that is how you would solve the system using the graphing method. Alright, now I'm going to do this whole thing all over again, but this time I'm going to do it algebraically. Alright, in the previous part of the video, I just solved this system by graphing. So if you wanted to see how I graphed it and got these two solutions, rewind and watch the problem just before this one. But now I'm going to use the second method, which we will call solving algebraically. Alright, so if you're interested in learning how to do this algebraically, watch on. But put your pencil down. Watch me do it, learn how to do it, and then go back and do it your own self. Okay, if I want to solve this system algebraically, it would be helpful to get y by itself. So I would subtract x from both sides. So that's going to give me y equals negative x plus 2. Now that I have the y by itself, I have something that I could take and substitute in to the other equation anywhere I see a y. Okay, so now I'm going to recopy this with the substitution. So that's going to give me, so I'm going to have x squared minus 2x plus y squared. But I'm replacing y with negative x plus 2. And then I have minus 2 times y again. And again, that's negative x plus 2. And that's equals 6. Wait a minute. This was y squared. I almost forgot to square it. Okay, and so that gives us x squared minus 2x. Now, squaring this means you have to multiply it by itself. So I'm going to have negative x plus 2 twice. Meanwhile, this one I have to distribute a negative 2. So negative 2 times x is positive 2x. Negative 2 times positive 2 is negative 4. Alright, a common mistake is just to put positive 4. But I'm multiplying by a negative 2, so it's a negative 4. Alright, meanwhile, I need to double distribute right here. So for example, negative x times negative x is positive x squared. Alright, negative x times 2 is negative 2x. And then 2 times negative x is negative 2x. And 2 times 2 is 4. Okay, so I have that. Now just bringing everything else down, I've got x squared minus 2x plus all this, and plus 2x minus 4 equals 6. So I need to clean all this up. So I've got x squared plus x squared, so that's 2x squared. Okay, now let's do all the x terms. So I've got this, and this, and this, and this. I've got 4 x terms. Okay, now look, the negative 2x and the positive 2x, they will just cancel each other out. So I've got negative 2x and negative 2x, so that makes negative 4x. Okay, so that was the x's, and then that just leaves the these constants. So I've got a positive 4 and I've got a negative 4, so they're going to cancel each other out too. Alright, so really that just leaves equals 6. Alright, so now I've got this. I need to solve this for x. I'm going to want to bring the 6 over here. So let's subtract 6 from both sides. So I've got 2x squared minus 4x minus 6 equals 0. My goal is to factor this. Now I notice that everything here is divisible by 2. Common factor, GCF. So we can divide that out because it's an equation. We don't need to save the 2 off to the side. We can just divide anytime we have an equation. So, and I'm going to put it over here because I need room. So that's going to leave me with x squared minus 2x minus 3 equals 0. So when I go to factor this, x squared can only be x times x. 3 can only be 3 times 1. Now I need a negative 2x in the middle. Now inner, I have 3x. Outer, I have 1x. I can get a negative 2 out of this if I have a negative 3 and a positive 1. So there's my negative 3, and here's my positive 1. Alright, but I need to set these equal to 0. So if I do x minus 3 equals 0, I'm going to get x equals 3. And if I do x plus 1 equals 0, I'm going to get x equals negative 1. Now I don't stop here. Solutions should be ordered pairs. Okay, they're points, not just x values when we're doing a system. So think of it this way. Think of a small t-chart where we need x values and y values. And so far we have these x values, negative 1 and 3. But we need the y values that go with them. Now we will get those y values using this equation right here. Alright, y equals negative x plus 2. Y equals, now I like to think of it as y equals the opposite of x plus 2. Okay, so if I want to find this y value, then y will equal the opposite of x, so positive 1 plus 2. So that'll be 3. If I want to find this one, y equals the opposite of x, so that'll be negative 3 plus 2, and that is negative 1. Okay, if that confused you even in the slightest bit, then I want you to understand that we could get these y values using the calculator and the table function. Okay, if I use negative x plus 2 as my function, alright, I take a look. I'd like to start at negative 1 since that's the first value I want. Alright, and I see negative 1 has a y value of 3. Alright, if I scroll down until I see 3, I see 3 has a y value of negative 1. So I could have gotten the values that way. So you do whatever makes you feel most comfortable. Either way, the solutions come out to be negative 1 comma 3 and 3 comma negative 1. And that is how you would record your answer. Alright, and you can notice that when we solve this by graphing, and when you solve by graphing, you graph the circle and then you graph the other equation as a line, and you see where they intersect. So notice that these values that we found algebraically are the intersection points. Negative 1, 3, 3, negative 1. Negative 1, 3, 3, negative 1. So you should get the same answer either method. Alright, for number 4, we are supposed to write the standard equation of the circle. So that means we're going to have to complete the square. So putting the x terms together, then I've got x squared minus 10x, and I'm going to leave a gap. And then putting the y terms together, I've got y squared plus 18y, leave a space, and that equals negative 6. So I must complete the square. So that's the half of the middle squared, and I put that here. So half of this is 5. Square it, you've got 25, so I'm going to add 25 to both sides. A common mistake is forgetting to add the 25 to the right hand side of the equation. For the y's, half of this is 9. You square that and you've got 81. So we have to add 81 to both sides. So these should all factor down as the same thing twice. So these x's will factor down as x minus 5 twice. And then the y's, this will be y plus 9 twice. Alright, in the meantime, this adds up to 100. Alright, and of course we will rewrite this as x minus 5 squared plus y plus 9 squared equals 100. Okay, so that is the equation in standard form that we were looking for. So I'm just going to recopy it in the answer line. So x minus 5 squared plus y plus 9 squared is equal to 100. That means that the center is the point 5 comma negative 9. It's the opposite of these two. And the radius, since this is the radius squared, that means the radius must be 10. Alright, obviously I'm doing the square root of 100 to find this radius. Okay, that's it for number 4. So looking at number 5. Okay, so we're supposed to write the equation in standard form from the graph here. So let's start with the center. And the center is at negative 7, comma 4. Okay, just double checking, negative 7 comma 4. That gives us the entire left side of the equation, because we should have x plus 7 squared and then y minus 4 squared. And here is going to be the radius squared. So we just need to find out what the radius is. Of course, we can just count. Alright, 1, 2, 3, 4. Okay, so the radius is 4. So since the radius is 4, 4 squared is 16. So this would be 16. And that's it for number 5. Alright, take a look at number 6. Write the equation of the line tangent to this circle at the point 3, comma 1. Alright, I think it's helpful if you draw yourself a picture. Okay, so here's a circle, and let's say that this is the point 3, comma 1. Okay, we need to know the center of the circle. So based on this equation, we can know that the center is going to be 1 comma negative 2. Alright, so somewhere in here we're going to have the center, and it's going to be at 1 comma negative 2. Okay, and so this is going to be the point of tangency. Alright, so my tangent line is doing like this. Okay, there's my tangent line. Okay. Alright, and so this pink line is the one that we're trying to find the equation of. So if you want to find the equation of a line, you need two things. If you think about the model equation for a line, which is y equals mx plus b, then that implies that we need two things. We need the m and the b, the slope and the y-intercept. So we're basically trying to fill this in. Y equals something times x plus something. So we need the slope and we need the y-intercept. Alright, so first let's go after the slope. So step 1 is we're going to start with the radius. Let's find the slope of the radius. Alright, the slope of the radius, so I mean here's the radius right here. And I can use the slope formula, which is y minus y over x minus x to get the slope of this radius. So if I do that, I'm doing 1 minus negative 2, right? So that's y minus y over x minus x, so that's 3 minus 1. Okay, 1 minus negative 2 is the same thing as 1 plus 2. Alright, so this is 3 over 2. So that is the slope of the radius. Okay, now we can use that to find the slope of the tangent line. So, which is the thing that we really need for our equation. So let's find the slope of the tangent. And that will simply be opposite and reciprocal for the slope of the radius. So if this is 3 over 2, positive 3 over 2, the slope of the tangent will be negative 2 over 3. Alright, it's got to be opposite in sign and reciprocal, so turned upside down as the fraction. And the reason for that is the radius will always be perpendicular to the tangent, and the slopes of perpendicular lines are always opposite and reciprocal. So we were trying to find the slope and the y-intercept. So far we've found the slope, negative 2 over 3. So that's going to go right here in the equation. All we need now is to find the y-intercept. Okay, so now we're going to find b. And the way we can find b is we can use y equals mx plus b. But we will use the slope m that we just found. But we will also use this point of tangency. Because they're giving us a point on the line, 3, 1, you see it is on the line, then they're giving us an x value and a y value. So if I use y equals mx plus b, then y is 1. So my equation starts off as 1 equals. And then I have m, so that's negative 2/3. And then I have x, which is 3. And then plus b. So you can see I have everything but b, so I should be able to find b. The way I look at it, these 3's cancel out, but if you need to put this in your calculator, because some kids don't like my common sense mathematical tricks, then you could do negative 2/3 times 3, which to me is the long way. But either way, you're going to get negative 2. So I've got y equals negative 2 plus b, and then of course I would add 2 to both sides. So that's going to give me b is 3. So that's going to wind up going here. And that's all we needed. So this is the equation. I'm just going to rewrite it. So our final answer is y equals negative 2/3 x plus 3. Alright, that is the equation of the tangent line. Alright, that's it for number 6. Alright, number 7. You can either solve this by graphing or you can solve it algebraically. Again, I'm going to do it both ways. So first I'm going to do method number 1, solve by graphing. Now, considering that I gave you the standard form equations, solving by graphing is going to be definitely the easiest method to use. So I recommend it. So if you want to see this method, keep watching. If you want to just see how to solve it algebraically, then skip ahead to method number 2. Okay, to solve by graphing, well, let's start with the center. Okay, so this first circle at the top has center -6, comma 7. Alright, it's just the opposite of these. And the radius is 5, alright, the square root of 25. So you can use that information to graph the circle. So -6, comma 7 would be right here. So there's our center. If the radius is 5, that means we're going 5 in all directions. So here's 5 that way, and then 5 in this direction, and then 5, you know. So this shows us where the circle is going to be. Okay, so your circle is going to look very much like that. Okay, now the other circle. So the center of this circle is going to be at -1, comma 2. Alright, the opposite of these. And the radius is still 5. So if I go to -1, comma 2, there's my center. Now I'm going to go 5 in all directions. So that'll put me here, and here, and here, and here. Okay, so if I go ahead and graph that circle, it's going to look like this. Alright, now the solution of a system of equations is the point where the two graphs intersect. So these two circles, you can see they have two intersection points. They meet right here, and they also meet right here. So these points are the solutions to the system. So this point is the point -1, comma 7. So that's one solution. And this point is the point -6, comma 2. Alright, so that is how you solve the system by graphing. That is definitely the easiest way to do it. So that's how I would do it if I were you. Okay, now let's look at how to solve it by algebraically. Okay, if you want to solve the system algebraically, then first of all we have to get these both set equal to 0. So see this -60, let's add that to both sides. Alright, so I would add 60 on both sides, so these would cancel out and I'll have 0. I would do the same thing with the 20. I would subtract 20 from both sides, so those cancel out and again I have 0. Now I can set these two equations equal to each other. Okay, so see, now I have set these two equations equal to each other. Notice the +60 that I created and the -20 that I just showed you. So anytime we set these equal to each other, the x squared and the y squared will wind up canceling each other out. Because the first thing I would do is I would subtract x squared from both sides and I would subtract y squared from both sides. Alright, but they both cancel out. So that leaves me with 12x minus 14y plus 60 is equal to 2x minus 4y minus 20. Now this is going to boil down to a linear equation like y equals mx plus b. So I'm just going to try to get y by itself. So I'm going to add 4y to both sides to get the y's together. Alright, if I'm thinking y equals mx plus b, then I want the y's on the left and the x's on the right. So that's why I'm adding 4y to both sides. So these y's are gone. So that leaves me with 12x minus 10y plus 60 equals 2x minus 20. Now I'm going to subtract 12x from both sides. And while I'm at it, I'm going to subtract 60 from both sides. So that way these all cancel out. So that's going to leave me with negative 10y is equal to negative 10x minus 80. If I divide everything by negative 10 to get y by itself, then I will have y equals x plus 8. Okay, so what I need to do now is substitute this back into one of the two original equations and solve. Okay, I'm going to use the bottom equation. So if I take this x plus 8 and I substitute it in for the y's here and here, so that's going to give me, so I've got x squared plus y squared, but instead of y squared I'm going to put x plus 8 squared. And then I've got plus 2x. Then I've got minus 4y, and I'm going to put minus 4 times x plus 8. And I'll stick with my minus 20 that I brought over. Alright, equals 0. So I need to solve this equation out. Remembering that this x plus 8 squared is really x plus 8 times x plus 8. Alright, then I'm going to have x squared plus, now as I double distribute this, I'm going to have x squared, then 8x and another 8x is 16x, then 8 times 8 is 64. And then I have the rest of this, so plus 2x. Let's go ahead and distribute, so that'll give me minus 4x minus 32. Negative 4 times 8 is negative 32. Minus 20 is equal to 0. Okay, combining like terms, so I've got x squared plus x squared is going to give me 2x squared. So I did that. Now combining the x terms, so I have 16 and 2x and 4x. I have to put these together. Well, 16 and 2, that's 18. Minus 4 is 14, so that's plus 14x. Alright, that leaves 64 minus 32, which is 32. Then 32 minus 20 is 12, equals 0. Now I'm noticing the common factor here, so I would go ahead and divide all these by 2. So that's going to give me x squared plus 7x plus 6 equals 0. Now it'll be my job to factor this. So as I factor this, I'm thinking x squared can only be x times x. 6 is either 2 times 3 or 6 times 1. Looking at the 7, I'm thinking 6 times 1. Alright, so inner I have 1x, outer I have 6x. If they were both positive, that would make 7x. So that makes these both positive. Alright, but then I have to set these equal to 0. And so if I have x plus 1 equals 0, subtracting 1 gives me x equals negative 1. And if I set this equal to 0, subtracting 6 gives me x equals negative 6. Now these are not the final answers. I need to look at this as a table of values. Okay, where I have these x values. I have negative 1 and I have negative 6 for my x values. But I need the y values to go with them. To find the y values, I will use the linear equation that I discovered over here. Y equals x plus 8. Let me just recopy that. Okay, if y equals x plus 8, then right here I've got y equals negative 1 plus 8, alright, which is 7. And right here I've got y equals negative 6 plus 8, which is 2. Alright, so that is going to give me the points negative 1 comma 7 and negative 6 comma 2. So that is how you solve a system algebraically. Now a moment ago we solved it by graphing, where we simply graphed the two circles and we saw the intersection points, and notice we get the exact same thing. So just understand, even if you do it algebraically, what you're really doing is you're finding the places where the two shapes meet. And that's not just for circles, that's any system of equations where there's two lines, a circle and a line, a circle and a parabola. You're always finding where they touch. Alright, so that's it. That was number 7. Alright, if this circle is translated 2 units up and 4 units to the left, what will be the equation of the resulting circle? Okay, well, think about the center of this circle. The center of this circle is the point 1 comma 3, right? Now if I move this circle 2 units up and 4 units to the left, okay, then I'm going to have a new center. Okay, if I'm going to use 2 units up, if I'm going to move 2 units up, then I'm going to make the y value 2 units higher because I'm moving up. If I'm going to move 4 units to the left, alright, moving to the left makes the x value 4 units less. So I would subtract 4 from the x value. Okay, so that's going to give me a new center of negative 3 comma 5. Now if you had any question about that at all, what you could do is borrow the graph from another problem and actually look at it and actually see what happens. I'm just gonna cut and paste. Alright, so let's look at it again actually on a graph just so you can fully convince yourself. If the original center was 1 comma 3, alright, that's the original. Alright, now if I translate this 2 units upward and 4 units to the left. Alright, so 2 units upward and then 4 units to the left. Alright, the new center of my circle would be right here. So it's going to go from being the point 1 comma 3 and end up with a center that is -3, 5. Okay, but as you can see, we did not need a graph in order to find this. But if you have trouble understanding, oh, I'm subtracting 4 from the x value when I move left, and I'm adding 2 to the y value when I move up, if that boggles your mind, then just borrow the graph from another problem and do this, and you'll get the same point. Anyway, once you have the new center, you can convert that to an equation. Alright, because putting this back into standard form, I would have x plus 3 squared, right, opposite of that. And then I would have y minus 5 squared, opposite of that. Now, we are just translating this circle. Alright, we're not making it bigger or smaller. So the radius should still be the same. So the radius squared, which is 16, that should also be the same. So this would be your equation. So that's it for number 8. Alright, last but not least, problem number 9. Okay, this is a review problem that has nothing to do with circles. This has to do with logarithms. So if I want to solve this, I see these bases that are the same, and when you multiply like bases, you add the exponents. Now, a common mistake is to make these bases just disappear, but that's not going to happen. Okay, I'm still going to have the 5. 2x plus x is 3x. 1 minus 2 is -1. So I've got 3x, 5 to the 3x minus 1 power equals 2. So, in order to solve this with the variable in the exponent, I need to change this from exponent form to log form. Alright, keep your eyes on the base. I'm going to bring this base straight down, but because I'm going to log form, it will be log base 5. Okay, now everything else other than the base changes sides. Okay, so these two items are going to trade places. So the 2 is going to come over to the left side of the equation, and the 3x minus 1 is going to go to the right part of the equation. So as I try to get x by itself, I'm going to end up adding 1 to both sides. So that will give me log base 5 of 2 plus 1 is equal to 3x. Please don't try to add these. Can't do that. It's part of a log. And then I will divide by 3 on both sides. Okay, I'm dividing this whole thing by 3. Alright, because that way those will cancel out. Alright, so that is going to give me the answer, but you can't type log base 5 of 2 directly into your calculator. So you have to use your change of base formula and rewrite this as log 2 over log 5. Okay, that's how you do log base 5 of 2. You do log 2 over log 5. And then we still have the plus 1, so don't forget that. Now all of this is over 3, like that. So I like to just type this whole thing in my calculator. Some students have trouble with that. But with the TI-30, it's not difficult. Please notice that the 3 is in the overall denominator. So if I were you, I would come down here, I'd make my 3. That's the denominator. That's the only thing in the denominator. Now in the numerator, I have a fraction. So up here in the numerator, I will now hit my fraction button again. And this will become your log 2 over log 5. So there's my log 2 over log 5. Okay, and then I've got the plus 1. Kabam! So that is the answer, 0.48 round up. Alright, and that is the end. But I will show you real quick. Students that don't like to type this all in at once prefer to just do this one step at a time. You have to do it without any rounding though, but you can. So for example, you could do log 2 divided by log 5. Alright, and you go ahead and hit enter. Alright, then we need to add 1, so you can just hit +1 and hit enter. And then we need to divide by 3, so you can hit divided by 3 and hit enter. And you'll notice we still get 0.48. Okay, so it doesn't matter which way you do. Alright, that is it for this lesson. I hope this video was helpful to you guys. I will see you on the next video.